Thank you very much. Is my audio on now? Okay, you can hear me? Yeah, I guess somebody's been reading my LinkedIn profile. Lots of flowery words and fancy things. Today I'm going to talk a bit about our Netflix OSS projects, and really kind of want to give you a survey of all of the different projects we've been releasing out so far, and a couple that are sort of right on the verge of being released. And I'm going to talk through, kind of show you the projects from their GitHub location and what they're called and what they do, and then kind of give you a view of how they fit into our architectural structure, and sort of our view of how we put together Amazon Cloud. And then I'll kind of show also how we do our distributed systems and how the different libraries from projects can fit in. And the whole entire talk is right there. So I'm using Prezi. So have any questions? So my name is Carl Quinn. I'm the engineering tools manager at Netflix. And so my team is responsible for building all of the tools, which pretty much whatever you would think of that's part of continuous deployment. So we take care of all the build tools, build automation, continuous integration tools, and also the deployment side. So even in the old DC stuff, we took care of that legacy work also, but now all of the tools that we use for deploying into the cloud. And all of the Netflix OSS projects you can find, the Netflix OSS is sort of our little banner there, and that tag is, you'll find it on LinkedIn, we have a group there, and on Twitter. So you can look for #Netflix OSS. So all of our projects live on GitHub, and we've got our own landing page that we've set up to kind of look like a little movie site. And you can see them there, organized with a little picture on them. And today I'm going to talk about the ones that I'm mostly familiar with. So there's a number that are related to structure and deployment and managing that, and also the ones that are kind of architectural platform-based ones. I'll talk a little bit about those as well. And there's a few that I just don't have time to talk about today. And most of those are related to the Cassandra area. So that's probably a whole entire talk just giving you an overview of those. And also the ones around Zookeeper. So I won't talk about those. So the ones that are still lit are the ones I do talk about. So there's a number of two core teams at Netflix that have been sort of producing a lot of these projects. And originally the platform team started out, they did a lot of the Cassandra work, and they started creating their projects and naming them after Greek mythology, right? So they started coming out with these various project names that are really hard to pronounce and strange, kind of, so like Archias and some of those. So when my team started to get ready to open source Asgard, it had it didn't have a name yet. It was just called NAC. It was just some acronym that really didn't mean much at all. And we wanted to come up with some kind of theme so that we can name things in a way that had some style to it. So we ended up coming up with Norse mythology. So we wanted to compete with the Greek mythology, right? A little more fun. So any of the names here that sound kind of Norse, those are from my team for the most part. And the ones that are Greek are from the other team. So we got this competing mythology going on. So almost all of our projects are in Java, or at least they're all on the JVM for sure. And so there's a lot of our tooling projects tend to be in Grails, just because we can put together quick apps, web apps, or little scripting tools. And some of the back-end services are written in Scala, so like EDIs in Scala. But all of those will be delivered as, if they're a library project, they'll be delivered to Maven Central. So you can find our Maven Central repo, and all the com.netflix projects are there. And those are all the library-based projects. And we're also setting up now on Bintray. So our JFrog's Bintray will be deploying there as well. And then that gives us also another nice opportunity, nice place to put binaries that aren't libraries. So we can share our wars and other deployable units that aren't specifically jars. And all of our builds in the open source world we've done using Gradle. So we have a nice set of standard Gradle plugins that work. So the builds can be simple and easy to use, and you don't need to install anything for the build tools. You could just grab them, and Gradle uses the Gradle wrapper to boot up and do your builds. We're migrating our builds internally to Gradle, but it's a lot more work in an enterprise build. We have lots of interactions and things that we haven't yet done it internally. But for the open source ones, that was a nice step to take first. So our plan at Netflix is to basically open source our entire stack. The whole group that reports under my vice president is kind of in charge of cloud architecture and infrastructure. And everything we're doing there is not really business specific to Netflix. infrastructure and things that you would just need no matter where you ran, no matter what kind of business you ran. So our idea is to just take all of that, and we would like to open source it and share it so that we're not the only ones sort of inventing this stuff ourselves. We want other people to be able to adopt this platform, contribute back to it, make it better for us, and make it better for everybody, but also sort of help grow the space and grow the usage of the cloud. So the more people using the cloud, the more it's going to become a commodity and the more efficient and reliable it will become. So we want to be a fish in a bigger sea. We want to grow the ocean so that we have more room to swim out there. So some of the challenges of taking a project that is fully functional, tested, and very reliable that's running in production and getting it out into an open source project. It's a lot more work than you might think. Especially you've taken something and built it and it works very well, but oftentimes we find there's internal dependencies. You've got you weren't really clean with your isolation and your layers, and you've got interactions between your component and other components that really don't need to be there, and which one do you open source first and how do you break those apart? So those need to kind of be cleaned up before we can open source things. A lot of times we make assumptions because you can take shortcuts. You can say, oh, well, we know that this is always going to be a certain way, and we just sort of hard code things in there. And we have to rethink those and either decide how to make those configurable or pluggable for other people. And a lot of times, too, there's just things that you would have done better if you had a chance to write it again. And so you go ahead and take the opportunity to rewrite things when you're going to go take it out there to open source. And so we have a little phrase that we say, something might be good enough for production, but not yet good enough for GitHub. And a lot of it too is just other people are going to look at your code. You want to be proud of what you put out there, so you take the time to clean everything up and document everything, and so it does take a while. So we're rolling out all of our projects sort of over time. They're all based on things that we are using in production. They just need a little polish before they can move out, and we kind of have to do it in a way where there's some kind of coherence in what goes out. So first I'll talk about kind of the set of the projects which are related to the structure of what we deploy into Amazon and how we treat the cloud. So this is probably the most complex thing to think about here. In Amazon, a typical deployment, you might have a cluster of machines in your data center. You'll set them up, configure the OS on them, and then deploy your app onto each of those machines and sort of treat them individually and try to make sure they're the same, but you don't necessarily know that you've configured or set up the machines exactly the same. Right? You get the snowflake effect. You might use Puppet or Chef to automatically try to install and configure the machines all together. But we've taken a different approach. We actually pre-create the machine images and leverage Amazon's ability to launch using auto-scaling groups to launch a cluster of machines or an auto-scaling group of machines, all based on the same machine image. So we do a little bit of extra work in the build cycle to actually produce a complete image and snapshot it and save it. And that's our deployable unit. So our build system effectively builds all the way out to the last possible bit. And then we can leverage Amazon itself in the auto-scaling system to scale up and create a group of as many machines as we want of that particular image. So it's very easy to reason about that one auto-scaling group is running exactly the same code, same version of the same app with the same configuration on all of the machines in that particular group. So that's one kind of design decision that we made. So when you scale up, you scale down, and this could even be for groups that aren't really scaled. You don't care, maybe you need a cluster of 3 machines, but it's still much easier to reason about it when you do it this way. Now we wanted to do something a little different with the way we did pushes. So when we want to roll out a new version of an application, the first approach we took was sort of modeled after the data center. We would just start and give the auto-scaling group a new launch config, effectively tell it about a new image, and then go through and kill the machines one by one, just like you might do in a data center where you bring one down and update it and then bring it back up. So we would just call this sort of a rolling push. And at the end of the push, everything worked well. You had a new version of the code. And then the problem is if you got halfway through the push, you're almost done, and then you realized the new version's got problems and we're starting to see issues. We need to undo. So how do we undo? Well, it's really tricky. You have to try to take the old version of the image, substitute it into the auto-scaling group, and then start killing the new ones. But now you've got a group of heterogeneous versions of things, right? And then maybe you accidentally got the wrong one to roll back to, and now you've got 3 versions of the same app running in your group, and you lose track of what's actually there, right? And so that was something that we really wanted to avoid in the first place. So we developed another approach for doing pushes that we call red-black push. So instead of sort of knocking off machine by machine through the auto-scaling group, we just leave the whole auto-scaling group alone. And we create a new auto-scaling group. And those two together we call a cluster. So effectively they're the same logical set of machines that will take the same kind of traffic. And so this whole notion of a cluster and how they're grouped together. And we have another notion of an application which just represents a service, a name of a service, and maybe a team that owns it and kind of what it does logically. And so those intersection between the two auto-scaling groups belong to an application, and they kind of together can form a cluster. There's a library called Frigga, which is just a small Java library which knows the naming convention. So most of the time, we try to use tagging in Amazon, because there's an API to allow you to tag objects so you can keep track of relationships between the actual Amazon entities. But in many cases, that wasn't there at the time, or there's just not an opportunity to tag things. So Frigga allows us to do manage naming conventions between things. So we just sort of build up the name of an auto-scaling group based on the application and the cluster and the particular push number and kind of this naming pattern. And Frigga assists that and lets all the different tools share the same code to do that parsing in a consistent way. So that's the bit about that and sort of our overall architecture. And we talk a little bit about our bakery. So the build process, it's a traditional Java build where we produce jars and wars and things like that. But in order to get that onto machine image in the Amazon world, AMIs or AMIs, we need to have a system that can assemble that together. So we do this in a two-step process. We'll start out with some sort of foundational AMI that is, it's like a Linux of some kind, so either CentOS or Ubuntu. So we're migrating to Ubuntu, and we're working on both at the same time. And we'll then use something like Chef to automatically add in, script-wise, a number of standard components. So we'll put on Java 6, Java 7, Apache, Tomcat, bunch of daemons that might run for monitoring and log rotation and all of the boot scripts, everything that every one of our apps is going to need. And we install that onto a image and snapshot that and keep that, call that a base image. So that's our base, and that's sort of our application-based image that will live and work for about a week or two. So that's the version that will be there. And that just sits in a pool ready to go. And then whenever any team wants to build and push a new application out, their binaries will work through the repositories and pop out. And the bakery, which we're going to be open sourcing, should be early March. This one's not out yet. But we went through a few naming. We were trying to come up with a Norse name for it, but something like oven or bakery. And if you name that in Swedish or Norwegian, it just sounds like English anyway. It just sounds like bakery. So that name didn't really stick. But somebody came up with the name Aminator, right? So it makes an AMI. So that was kind of cute. So that's what we're going to go with. And what it does actually, and this is an interesting technique, is so we use EBS volumes, which is a block storage system in Amazon, and that's one of the kinds of AMIs that you can make. It's a snapshot of basically your disk image that's in block storage. You snapshot it, you register it, and kind of give it some identification and description, and now you've got a disk drive that you can boot from. And so what we do is we take and we just mount multiple volumes of the base image on just a node sitting there in the cloud. And once you have that mounted, we can play a game where we cheroot into it and then do installs on top of that. So we're not really running or executing that machine's image. We're just sort of pretending, and we're going in there messing with the disk image itself. And we have to play a few games with service startup scripts and stuff like that. But it's pretty nice once it's going, because we don't really have to even boot anything. It's just a mount, drop in a few things. So if you've got a Java app, it might just be a WAR file, a couple scripts, snapshot that, register it, and we're done. The whole entire bake process here can maybe be done in about 3 minutes. So it can be part of a continuous deployment system where we're just, when you got a new build, you got a new release, boom, it comes out, and now you have an image, and it runs in. Then the image can be available in every region that you have production machines. In this particular example, you see I've got a library or a module, version 2. So this is our application. We want to deploy it. So version 2 kind of goes through the pipeline. You can see it's being added on to the mounted volume, which contained the base. Snapshot it. Now you have the app sitting on top of the base. You've got a new AMI, version 2. That goes out, and that becomes the version 2 that's then pushed out to the cluster and becomes the next version in your red-black sequence for the cluster. So version 1 was running, now you want version 2 out there. And once it's up, you can run traffic against version 1 and version 2. We can control switch traffic off of 1, but keep it around in case something goes wrong with 2. So we have a way to fall back and then automatically manage cleaning up of 1 or rolling back, rolling forward. So the next tool that I'd like to talk about that's open source is Asgard. So that's our deployment management tool that we open source last June. That was quite a bit of work to get that cleaned up, but now it's available, and it's actually being used by a number of different teams externally. We like to try to find out who's actually using our stuff. In this case, the Obama campaign team used Asgard to manage all their deployments for their cloud system, so that was pretty exciting for us. And it's a Grails app, and it shows, it's good for like navigating and browsing through all of the objects in your account. It can show you all the things, all your images, all of your instances, all of your auto-scaling groups and clusters and volumes, and just sort of, a page-oriented navigation thing. And it can also do pushes, so it can help you manage your clusters and do your red-black pushes and kind of takes care of the workflow of that. And here's kind of a sample screen of what have we got here? Just auto-scaling groups in our Virginia test account. Another tool that we have that we've just released, I think a couple months ago, is called Edda. And Edda is written in Scala, and its goal is to sort of watch everything that's going on, looking at the entire account, all the objects that are being created, just sort of scanning every minute, scanning, and storing all of the changes of everything that's been happening into a Mongo database. But this is just a RESTful endpoint. It doesn't have any GUI or anything on it, but it allows all the other systems and services to hit it and ask questions about things. So one example might be, let's say you're looking through logs and you realize that something was going wrong and a certain machine was hammering your cluster last week for 4 hours with weird traffic, and you want to know who it was, what happened. But that machine's gone in Amazon. You see this IP address, but there's nobody there anymore, so how do you know what that was? So Edda can come back to a query. You can ask it and set up a query and say, well, what was at this address over this time? And it can give you back a description, basically using the same kind of JSON information that Amazon has, but now we've recorded it in time, and it can say, hey, that was this particular service, and it ran, and is this version exactly everything you would need to know to go and then maybe diagnose that machine or talk to the owners of that particular application. So another one of our famous projects is the Simian Army. So Chaos Monkey was one of the first projects that we had that we talked about and Amazon embraced, and that's sort of the t-shirt that I have on today. And these monkeys are basically just an automated system to perform certain mundane operations for us. So the Chaos Monkey is interesting, and its goal is to actually create chaos. If you really want to make sure your distributed systems are robust against failure, because you will have failure, especially in a public cloud environment, you need to make sure that everything you've written, every piece is going to deal with the kind of failure that's really going to happen. And so what Chaos Monkey does is runs around and just destroys things, terminates things. There's a UI for it that will let you sort of manage the scope of the chaos, how often you want to be messed with. You can opt out a few services that you're really not ready to deal with, but for the most part, the whole point is to be able to make sure, kind of work through this checklist to make sure all of your apps, all of your services are able to deal with this kind of chaos, on a regular basis. And you'll find things as we're deploying to test a new version of something we think is fine. The Chaos Monkey will hit it. Something will blow up in a weird way that the guys hadn't, they introduced some kind of dependency they didn't realize, and it's a good way for them to become aware of anything that they missed. Janitor Monkey is a newer monkey we released later this fall, and it's actually probably very useful for anybody right away. If you're in Amazon, its job is to kind of go through and look at all of the objects that you've got created and just kind of give you the ability to add rules to dealing with ones that are old or stale or unused, and just help you clean them up. It can give you messages and reports based on what appears to be old, and you can actually set up rules with it to automatically delete stuff for you. So we have a UI for it that's not yet open sourced. It needs to get integrated back into Asgard, so it's just a Grails app. So it'll become a set of pages in Asgard, and in this particular example, it's the potential targets that are going to be cleaned up in this particular region, all resource types. This is probably a week's worth of things to be cleaned up. So it's just going to mark and sweep through every week and clean up things. And this can really help save you money if you've got lots of volumes and snapshots of stuff sitting around that. In our environment at Netflix, the engineers are very, they're enabled to do a lot of work and do a lot of use of these tools on their own. There's no committee to keep track of who's doing what and management of allocations and quotas. People just do what needs to get done to get their work done, but then we have to create these tools sort of follow up after all the engineers and clean up stuff that they didn't clean up. You don't want to have to worry about it. It's like garbage collection for machines instead of for objects. So recently, a lot of the teams that were doing large-scale integration testing and build automation were writing their own scripts, Python or Shell or Java, Ant plugins and things like that, to kind of talk to all of our services to automate things and automate test deployments, nightly smoke tests, things like that. So we got together and sort of figured out what was the core set of functions that they needed, what services they need to talk to. And we put together a library. It's just a Groovy library, client library, it's just REST client. And it allows any of our teams to basically script using Groovy, very simple kind of, not really a DSL, maybe it's kind of a DSL, but it's mostly just a Groovy library that is very easy to chain together in a simple kind of linear flow. And here's an example of what it looks like. This would mostly be used, maybe you would run automation on Jenkins that would run this code to do an integration test and push. In this case, we're making a cluster, and we're going to do a red-black push into the cluster, let it succeed, and then trim the oldest groups, wait for them to complete. So it reads pretty well, and it's easy for test engineers to use and automation engineers. So this will be open source probably next month. I'm going to grab a little more water. So the next bit I'll talk about are the projects that are related to sort of how things are connected together in the cloud. So most of these come from the platform team or other teams that have contributed these, and they mostly relate to how the machines communicate. So one of the first things, little guys at the top, so I'll give you an idea of this picture here. The little guys at the top are Amazon Elastic Load Balancers. So in our typical architecture, we have the load balancers using ELBs talking to our front-end services. Those front-end services then in turn might talk to middle-tier services. And then finally in the back of the chain there is going to be a service that will talk to storage of some kind. And most of the time for our production storage, that's going to be Cassandra. When we first went to the cloud, we really wanted to kind of replace our DC architecture, and we used hardware load balancers everywhere, between the tiers, so like NetScalers and things. But we didn't really have anything exactly the same in the cloud. We had ELBs worked okay for the front end, but really weren't a great solution for middle tier load balancing. So we put together a little tool, a little service that we called Discovery that was used for both a combination of service lookup and kind of load balancing. And what we ended up doing is we did the load balancing itself. The actual message routing is done in the client side. And all the Eureka needs to do is, Eureka is the open source project name for the thing that we had originally called Discovery. It's kind of similar words. Yes, Eureka, I've discovered it. So it's mostly about service discovery. But this sort of is our central, the heart of how we do the middle tier service discovery and load balancing. So let's walk through a typical application and when it comes up and the different tools that we have to help you configure it. So Archias is a library which it supports annotation in Java for annotating properties that we call fast properties internally. And these are properties that can be configured from property files or default settings in your code, but they can also be configured from dynamic values that are coming from some kind of storage. Internally, we have kind of a different storage backend that's sitting on top of SimpleDB, but the open source version of it is got a plugin that talks to Dynamo. So this is Amazon's Cassandra-like DynamoDB. It's really nice to use for this low-level kind of configuration things. It's not high-volume production data, but it's the kind of tooling information or meta information. It's nice to rely on Amazon's offerings because it makes it simpler for us to bootstrap our systems. So we don't need to get the Cassandra in there before we can get the properties in which Cassandra needs, and so we avoid a chicken and egg problem this way. So applications, when they start, can grab and be configured. And so what we can do with Archias is have different clusters getting different settings for their values based on just sort of what you've set up dynamically, or different auto-scaling groups, so you can tune the settings based on any kind of logical or group organization of your machines. Then back on the client side for the networking traffic, so Eureka is the server, but Eureka also has a client library in Java. In that library, sits at the lower layer and talks to Eureka to find out all of the machines, information about all of the machines that your client might talk to. So in this case, we're talking to the service below us. We're going to want to know about that. We're going to want to know about all of the different instances that are currently available. And it keeps a connection to Eureka all the time. So every machine registers with Eureka to say, I'm alive and I'm healthy and here's my heartbeat. Who's available right now for me to talk to? And Eureka will send back all that information. And then the Eureka client will make decisions about how to go through, select the set of machines to actually talk to from the cluster below it that it wants to talk to, and figure out how to do round robin through those. And there's a few different schemes that can do simple round robin or weighted based on load information from the machine. So it's taking care of this selection of who to talk to. And then Ribbon is a brand new library, which when I first gave this talk wasn't there, and now it is, and so I've added it in. It actually takes care of the RPC itself, so doing Java REST RPC and the actual connection and traffic management there. That one got chopped off a little bit. So I zoomed in a little too much on this one. Hystrix is another service that's similar. This actually came from one of our application teams that had a need for it. So they were the API team that lives on the front end, and they have so many downstream dependencies that they were really, really struggling to keep up any kind of consistent reliability. Because they, if they're sitting on top of services that are all maybe giving them 3 nines of availability, or maybe 4 nines, if there's 50 of those downstream services and they're all sort of sequentially aggregated, and you're trying to produce some kind of result based on all of those, you kind of get the worst of everything. So if any one of those goes down, it can bring the whole thing down, and threads get blocked up, and performance was always a problem. So what they did is come up with this library and a technique that was called circuit breakers. And Hystrix is the encapsulation of that library, and now it's shared throughout Netflix and open sourced for anybody else to use. What it does is keeps track of the connections. It manages the threads that are being used to talk to the downstream services so that you don't have to deal with those threads yourself. And it keeps track of the success of the calls. So you may be calling a downstream service and it's noticing that they're starting to become more and more latent, and the performance is getting bad. And there's settings that you can tune in your application. At some point you're going to say, okay, this downstream service I'm calling is got trouble. Hit a threshold that I've set. I'm going to stop talking to them, and I'm going to fall back to a cached version of the data maybe, or I have some computation I can use, or I just ignore that bit of data and I can get by without it. And we'll shut off traffic And your application code in Hystrix, it doesn't have to know that this has happened. So you've got a layer in between there that will just automatically reroute and provide, replacement data or no data, depending on what you've configured for it. And then Hystrix itself will register what's been happening to a centralized server called Turbine, which can visualize that and let people look at what's going on, but also help keep track of who's having trouble with what. So if one downstream service is giving consistent problems, you'll see it in all of the guys above it that are trying to talk to it. And they'll independently circuit break and stop talking to it, which kind of gives that team who's managing the downstream service some chance to get away from the load and figure out what's going on and recover things. Another pair of libraries that we have, Servo is a library which you can use in your Java code. It's annotation based as well. It lets you add monitoring hooks, basically, to tell which of your variables, for instance, like tracers, counters, and things that you want to measure and monitor on your system. The Servo library itself will take all that data and publish it out through JMX, and then we have daemon that runs on the machine and gathers the JMX data from the JVM process, as well as gathering other data that's sort of system-oriented and pushes it towards our Atlas service, which will be open sourced at some point too. But Servo can also be used, you can push it to other places. So you can push the metrics to CloudWatch, which can then be used to manage your auto-scaling. So if you wanted to configure auto-scaling based on some kind of transaction count inside of your JVM, you can annotate the right variables there, push them out through, and then publish them to CloudWatch. So now you have a metric that you can use to scale your auto-scaling groups. And it's pluggable, so you can have it published to any other kind of monitoring system that you've got, or logging system. And Blitz4j is a logging library, sort of works with SLF4j and Log4j kind of world. It's just a particular logger that's a lock-free logger. So it executes very fast, it doesn't block. It's very good when you just want to get stuff out. And we write a lot of logs, but you don't really want the logging to impact the performance of the application. So this is a nice way to make that go fast and not become a problem. And that's the end of the prepared part of the talk. The reason Netflix lets me roam around the world and talk about things is because it's sort of, this is kind of our hiring. So we are hiring. If you're interested in moving to the United States and working for Netflix, we're hiring. It's interesting. So I've been doing this talk or other talks like this abroad a few times, and this is the first time I've actually been somewhere outside the United States where the country actually has our product. So it's kind of exciting. And so I knew that they were talking about which countries we were going to deploy to. I was voting for us to go Nordics. So that'd be good. So yeah, I hope you guys are using it and like it.
Yeah, I'm definitely using it. So anybody has a question for Carl? Yes, I'll run with the mic.
Hey, Carl. You talked about the complexities and the costs of publishing everything as open source, cleaning up the code and all that sort of thing.
Right.
So I wondered, what's the corresponding benefit to the business of publishing everything as open source?
Oh, so the benefit to the business. So I guess there's a number of them. And for our management, the number one selling point that made this work for us is hiring. Because we can put our projects out. This creates a big buzz. We can talk about them. We can have meetups. We can have open houses, which actually we're having one today. But none of us could get there in time. It's all the way on the other side of the world. But it's a way to get people talking about Netflix. And it's just like a lot of companies like Google. We want to be known as a company that does high-tech, bleeding-edge things, and it's a great place to work. And so putting our code out there for everybody to look at is one of the best things we can do. But from my perspective as an engineer and a manager managing a team of engineers, it's also a good way to make your code better quality. Because it forces you to look at it from other people's views and say, this piece of code, it's fine. If nobody looks at it, I'm fine pushing it to production. But if a million people are going to look at it on GitHub and say, what is he doing? It makes you think about it a little bit more. And also having it out there and other people using it, you're going to get more use cases and more eyeballs on it, and it will improve the quality of it. And so we're finding that as well. More questions?
Thank you. Any additional questions?
Right here.
Do my little run. There was one here.
So I've been using Netflix for a couple of months now in Sweden. And one thing that I've noticed is that it's, in contrast to almost all other similar services, the playback is more or less flawless. So I was wondering if you could tell us a little bit about how the movies are actually served.
Okay. So, let's see, where do I start with all this? The movie content. So the bits, movie content bits are encoded. We use, basically batch processing encoding in Amazon, and the final encoding bits end up in S3, and then we push them out over CDNs. So traditionally, we would use Akamai, Limelight Level 3, and they're just big blobs of movie files, and they're already encrypted and everything. So once they've been encrypted, they can be moved around on a public network, and they're fine. We actually have our own CDN system that we put together called OpenConnect. And here in the Nordics, when we launched, we had OpenConnect was ready. So you're entirely on OpenConnect here, and that's why you're seeing such good performance. We basically have racks of machines. It looks like just a rack-mounted 19-inch machine just stuffed full of hard drives. And those act as caches that are distributed throughout near different peering points. And every night they get instructions, or they phone home to ask what movies are popular, what movies do I need to go get, and the machine will then gather, and they can even do peer-to-peer transfer to make sure that what they've got cached is the movies that most likely people are going to ask for. So that really gives you really good bandwidth of transfer for the actual movie bits. As far as like playback speed and usability the clients on all of the devices that we have are actually quite smart. So really just doing HTTP gets for chunks of the movie bits. And the client will typically get a bunch of information. When you first hit play, it'll get a bunch of metadata. It'll get keys, so it knows how to decode the content, decrypt the content. And it will get a bunch of URL information, so it can find the movies no matter where they are. It'll get a number of different endpoints that it can find the movie. And it will start streaming. It'll pick a lower bit rate initially to make sure, as it starts streaming the movie, it'll be measuring the bit rate, seeing how good things are, probably ramp up the quality level as it goes, and start playing there. So you're going to see playback right away. If something starts going wrong, like if it starts seeing latency problems or buffering problems with that particular CDN or that endpoint, it can switch on the fly in the background and switch to another one and look for more, and actually keep multiple ones going at the same time. So the client's very smart. The server side for the stream is really dumb. It's just HTTP server. It could be anything. So we've put the smarts in the client there. So I think between those two, our service ends up being, I think, one of the best user experiences for playback of video. Ability to deal with bad and slow, connections and adapt and give you the kind of the best experience that, for your given situation.
Okay, now we're all the way in the back here.
Oh.
Hello.
Did he? Yeah.
And we have another question.
Hi, we're using Amazon as well, and we've had some issues lately with the elastic load balancers, with parts of the server, parts of the load balancer starting to not work. We're trying to figure that out with Amazon. I'm just curious if you've had some kind of the same issues.
Yeah, I would say as far as the components we get from Amazon, the ELBs are probably the most troublesome. We had a Christmas Day outage for 10 hours because of ELB problems, took out the whole region. I don't really know what the answer is. We're pushing on Amazon to deal with some of the issues around ELBs and the reliability and scalability, and hopefully they will address those. If not, maybe there'll be some alternatives. You're not really forced to use Amazon's ELB to do your load balancing. It is, after all, just an instance that's running some load balancing software. It's just a Linux box, so you could do your own kind of thing. There's third-party load balancers you can use and just fire up a cluster and set up your own load balancers. That's one kind of fallback if you're really having trouble with them.
Excellent, thank you. Another question?
Yeah, I've got a follow-up question on the open sourcing.
Yeah.
I guess there's some kind of line between open sourcing stuff and contributing to society and gaining PR on the recruitment market.
Right.
And there's the other side where you do not want to spill the beans.
Mm-hmm.
So how do you reason around where do you draw that line?
So I think in our case at Netflix, it's almost the way our company is organized. So my VP is in charge of cloud. What's our title? What's our group name? Infrastructure and cloud. It's got some big, funny, long name. It's basically everything that's not business, what our business is about. So Netflix is about movies. So everything like movie discovery and matching movies or TV shows, the right content to the right people, all those smarts and the algorithms for search and matching, that's what we think is our core business. Everything that's about deploying code and managing clusters and doing monitoring and metrics and graphs, and that's just sort of generic, and we would buy that if somebody sold it, something that we could buy. So everything in that category, we're better off open sourcing it to share it with people so that we can improve it for everybody. It's kind of the rising tide kind of problem. It's not core to Netflix. So that division works for us really well. I don't know if it works as well for every company, but if it's something you think you could just buy off the shelf, but you wrote it because it wasn't there yet, that's probably a good thing to open source and share with people.
And we have time for one last question. Who wants to share a question with us?
Actually, I have one little nitpick about the Swedish service of Netflix.
Uh-oh.
Yeah, it's a pet peeve of mine. You can't turn off the Swedish subtitles. You can't turn off subtitles at all for certain content, such as Buffy or Dexter.
Okay.
Are there any specific difficulties in adding the off option?
No. I think a lot, I'm not sure about this particular case, but a lot of the burden that we have with dealing with subtitling and alternate audio is getting the metadata from the actual content providers. And this is something that we have a whole new division in our company that's trying to create this new pipeline. But if you imagine buying a movie from a studio and they say, okay, you have the rights, we've signed the contract, now we got to go find the bits. Who's got the actual movie bits? Who's got the subtitles? So you end up for like one show, one TV show, one movie, pieces of the digital asset might be coming from a dozen different places. So like the Swedish subtitles might be coming from a company that's a subcontractor of a subcontractor that's in Denmark, and the other things are coming from other places, and they don't even know how to get it to us. So we scramble just to get what we can get and get it encoded and properly, all the metadata properly tagged and delivered. We're trying to push to a system where it's much more fully automated, and we push that work back on them, and they provide that. And that gives us a way to understand what we have and make it all switchable and available. So I'm not sure what you ended up with is something you might have subtitles that are actually in the video stream, and then there's no way to turn them off. So that's probably what happened there. That was the only way for us to get the asset. But hopefully that'll fix itself. If not, you should call in. Or I think you guys here have the predominant form of customer support is live chat, so yeah.
Thank you so much, Carl Quinn, for coming here all the way from California. Carl is going to be around for the entire conference, so if you do have any questions, please feel free to grab him during the conference, and let's give a warm hand to Carl Quinn.
Thank you.